2021 GCE Admin Paper 2, Question 5. A group of 5 children consists of 2 girls whose names are Mary and Sarah, and 3 boys whose names are John, Joseph, and James. If these sit in a straight line on 5 chairs, find the number of different possible seating arrangements if Joseph must sit in the middle. So we have 5 children here. 5 children. Let's just write down their seats. I don't know if okay, let's just make it like this. No need to draw anything funny. So the condition we've been given here is Joseph must sit in the middle. So once Joseph has been assigned a seat, then we only have 4 seats to assign the other students. So in short, John can be assigned in one way. Actually, this is Joseph in one way or 1 factorial way, because he can only be in the middle. And then the rest of them, we have this one here. Since we are remaining with 4, the first slot can be occupied in 4 different ways. You can either put Mary, John, Sarah, or James. Any of the other 4 can sit on this. So we have 4 ways of assigning this seat to someone. And then once you assign someone there, you're remaining with 3 people to arrange. And then once you assign the first 2, you have 2 seats to arrange. And then finally, the last seat can be occupied in one way. Of course, Joseph is alone, so this is just the 1. So we actually have 1 factorial multiplied by 4 factorial ways of arranging these guys in such a way that Joseph is in the middle. So we have 4 times 3 times 2 times 1, which is, this is 6 times that, we have 24. So I have 24 ways of making such arrangements. And then the second condition is Mary and John must sit together. So we have 1, 2, 3, 4, 5 students. And then let's assume these 2 are Mary and John. So if these 2 must sit together, then we technically have 1, 2, 3, 4 students. I don't know, are they students? 4 children, whatever. So we have 4 children to arrange. So in short, we can arrange them in 4 factorial ways. But don't forget, these 2 are also allowed to permute. You can either have this one first or this one first. So as long as they are together, the rest doesn't matter. Whether you start with this or that, that's none of your business, as long as you put them together. So now you can arrange these 2 girls, actually these 2 children, in 2 ways. So that's 2 factorial ways. So when you work this one out, you have 4 factorial, which is 4 times 3 times 2 times 1, multiplied by 2 factorial, which is 2 times 1. And then when you multiply, this is 24, and then times 2, we have 48 ways of arranging these 5 children with a condition that John and Mary must sit together. Lastly, a group of 6 designers is to be chosen from 8 men and 15 women. So the moment you hear this word here, chosen, just know that we're talking about combination. Because we just want to choose. In fact, this is easy to remember because they both start with C's. So a group of 6 designers, the total must be 6, is to be chosen from 8 men and 15 women. So find the number of ways of choosing at least 5 men. So at least 5 men means you can have 5 men or 6 men or more men if you still have more. Yeah, we have 8 men here. So you can have 5 men, 6 men, or 7 men, or 8 men, but then remember the total here is 6, so you can't go beyond 6. The total number of people in the group must be 6. So you can either have 5 men or 6, not 7. So forget about all the other numbers beyond 7, but the word at least means 5, 6, 7, all the way to all the men. but we have this condition here. So let's work it out. So and means multiplication, then the word or means plus. So in this case, you can either have 5 men, and remember the total must be 6, and 1 woman, or you can have 6 men and no woman. So now let's choose 5 men from 8. So we have 8, choose 5. Remember, and means multiplied by. From the 15 women, we are choosing 1. Or means plus. So we are choosing 6 men from the 8. And no woman from the 15, like this. So now when you punch 5, choose 8, choose 5 on your calculator, you get 56. Then 15, choose 1 is just 15. You can verify that these are known combinations. Then 8, choose 6. 8, choose 6. This will be 28. Multiplied by 15, choose 0 is just 1. You can verify that. So this is just a 1. And then now let's multiply 56 by 15, which is 840 plus 28. And then when you add these two numbers, you have 868 ways, and you're done.